All right, we are live. Hi, everybody watching at home. We are just going over the answers number 4C. They are as follows. 1 through 4 says graph negative f of x. It should be flipped completely upside down. So number 1, 2, 3, and 4. So what you should have, I'm going to read from left to right. I hope this makes sense, otherwise I'll just draw it. It should go diagonally down, then up, then down, then flat over. Okay. Number 2A, I'm kind of skipping around. Number 2A should be across, then down, then across, then up, then across.
Oh my God.
What exciting.
They're doing the Jabberwocky.
Number 1.
Why?
Lewis Carroll. Number 3. The thing is just flipped upside down. So it should be curve up, then hit 0, curve down, hit 0. Next.
Oh, that's a pain.
1, 2, 1.
Number 4. It's similar to number 3. It should be curve down to 0, curve up to 0, curve down to 0. That's all the A's. For B is absolute values. Every single thing that dipped below 0 should be reflected above. So there should be that little snippet that's going down in number 1 should be coming on the upper side going down. Do you see where it goes down to that little valley at x equals 1? It should turn into a teeny little mountain at x equals 1 above that. Does that make sense? Should I just draw this?
It's fine.
Okay. Number 2, well, just for example, if you had something like this, I'm just making this up. If I wanted to take the absolute value and make it dotted, it would look like this. This is just made up. So all the negative things got flipped out. That's how you do all of it. And then number 3, it should be just sort of 2 round mountains there. And 4, there should be 3 round mountains. Number C, if you make x negative, you're flipping it over the y-axis. So the whole thing just sort of pivots. So, let me see what that one was. Okay, so here's the line. It went like that. And then the x-axis was here, or the y-axis rather, was here. If you flip this around, if you have f of negative x, it should look like this. This side is over here. Oops, I have an x-axis, shouldn't I? Should look like that. As if they just spun it 180 degrees and sort of flopped these 2 sides. That's for number 1C. Number 2C should look almost the same, except that sort of top surface on the right should be on the left-hand side of the y-axis. Number 3 should look reversed. There should be an upward hill on the left and a valley on the right. Number 4 should be absolutely identical. Number 4C. Okay. Those 1, 2, 3, 4. Number 7. Sketch the graph and then the reflection of the graph. Y equals 3x minus 4. This one I better just graph. 3x minus 4, hopefully you remember slope-intercept form. Go down 4. Rise 3. Gentlemen, I'd appreciate it if you pay attention. Rise 3, 1, run. How do you do its inverse, Jack Lau?
Oh no, not this one. This one I didn't see that
You know my response to that, yes.
well, it was through y equals x, I think,
True.
right?
That's
Which
true.
Goes through the origin on the diagonal.
Correct.
And then,
How do you actually get the graph?
Switch to line X.
You trade X's and Y's. The inverse, the line Y equals X. The only reason that's the central line is because if you swap X and Y, it makes no difference. That's the only line, diagonal line where that's the case. I mean, except for, no, I guess that is the only one. So if you invert it, X equals 3Y minus 4. The only catch is get Y by itself, which is one of the reasons why I'm having people tune in, especially if something's looking like. So it's X plus 4 equals 3Y. And then divide both sides by 3. I would divide each and every one by 3 if you want to graph this. Y equals 1/3 X plus 4/3. So now 4/3 is awkward. That's all right. So do 1 and 1/3. And then the slope is up 1 over 3. So the up 1 is kind of awkward. It goes up to 2 1/3. And over 3. And if you do it correctly, they should intersect at exactly the line Y equals X. Okay? So this is the original, and this is the inverse. It's a mirror image over the line Y equals X, but the way to graph that and to get the formula is to trade the X and Y. And again, this wasn't the most fun thing to graph. I'm not going to judge on artistic merit there, as long as it's close and as long as you mark. Oops, which I forgot to do. As long as you mark the points. Everybody got number 7? Can you do that on a test? Got it all? All right, number 7's done. Number 10. X squared plus 3x. Let me do that on here. Y equals x squared plus 3x. Again, the inverse is x equals y squared plus 3y. Now, it should be an absolute mystery as to what that, we've never graphed anything like that before. We have graphed things like this. Can somebody tell me how? There are multiple ways to graph this. What shape is it, first of all? Paul, take over. What shape is this? Parabola. Does it factor?
Yeah, you can pull out onto the X.
Yeah, what's left behind?
And you have X plus 3.
Good. Can you tell me where the roots are?
It's going to be just at -3.
And
0.
at 0, correct. There are 2 roots. That, what's another name for root, by the way? On a graph. Good. X-intercept. Take over.
So you can actually put those in the graph as x-intercepts?
Correct. I need at least one more point in order to graph this thing. Go. So,
I
questions?
just have a question. Why, do you have to use the original thing instead of the inverse one?
Not necessarily, but graphing this straight away would be really hard. You can. It is possible. Did you use the table, or what did you use?
I just, like, did it, I think I just did it the same as like a normal drawing, like I said, it's always gonna say the same.
Correct. This one would actually go sideways. It's opening to the right. So it's a strange one. So that's one of the reasons why I'm scared to do that, because we've never seen this before. It's just alien. We do know on this one it has roots at 0 and 3. Can anybody tell me what the axis of symmetry is on this? Julie Miller. I'll give you a hint. If you have a parabola that goes like this, where would you look for the axis of symmetry? Right in the middle of that. Correct. Halfway between these. This is 0, this is 3. It's not going to be a whole number, but it's 1.5, or 3 over 2. So x equals 3 over 2. You can actually give me a good estimate on there. The vertex, can we just, using detective work, do you think the vertex is below or above? John?
No, below.
Why do you say below?
Because
You're right.
it's going up and it doesn't have a negative height multiplier.
Correct. The thing is opening up. So in order to open up, it had to start from below. Can anybody tell me where that actually is? So it's below, but where below? No, take over.
You plug it in.
Plug it in. So now it's not exactly fun, but, well, it builds character. Y equals something squared plus 3 times something. Plug in your something. Go for it.
That's 9/4.
Sorry, I'm slanting by the way. Plus,
6/2.
no, 6/2, but
Or 9/2.
9/2. And then common denominator?
You can multiply the 9/2
Okay,
by 2/2,
okay.
and 18/4.
18/4, go ahead and add those up.
And you get 27/4.
27/4, so that's 6 2/3. 3/4, okay. So this is -6 and, wait a minute. Did I plug, oh, it's supposed to be -3, yes, done. Oh, that's, I'm an idiot, wow. Man, I was wondering why it was so far down. This is -18. Try that again, my fault.
9/4 negative.
Yeah, -9/4. I forgot to plug -3/4 in, or -3/2 in. So that gets squared into its positive. This one is negative. All right.
So
Why did I do that?
wouldn't the graph be on the other side then?
I'm sorry. Would that graph with the inverse? Or this one?
This one.
Okay, this one. It's -3. Oh. That would explain a lot. You're absolutely right.
You said you knew that?
I need that.
That sounds so, let's do that. Can you do that?
No, I will mortify my desire for that for now.
But can you do that, like, legally?
Not in the instant, no. So this is x equals -3/2. And yeah, this is going to be -9/4. That's better. So there's the parabola. Do you remember how many points minimum you need for a parabola?
3.
3. 5 is better, but 3 is minimum. 2 is not enough. Take a look up here. How do you find this graph? There's a very easy way to do it once you have the first graph. How do you find an inverse again? Go.
Oh, will you just switch stuff?
Exactly. Let me highlight these points. This is -3, 0. This is -3/2, -9/4. And this is 0, 0. Give me 3 points of the new graph. Sophie, take over.
So would it be 0, -3,
0, -3. Okay.
0, 0.
Yep.
And then -9/4, -3.
Correct. So -9/4, -3/2. And that should make a sideways problem. There's your inverse graph. In other words, the only way we know how to graph an inverse is to graph the original and then flip all the points. Okay? I mean, if we're lucky and we transfer it over to an inverse and it's a nice formula, like this was slope-intercept, even though this was kind of icky. What you could have done on this one, if you wanted, you see this point 0, -4? And then I think this is like 1, -1. Guess what you could have done? Flip them. This would turn into 4, 0, or -4, 0 rather. And then this turns into -1, 1, and it works. We get the same one. Okay. Number 10 good? Alrighty. After number 10 was 12. Y equals radical x. Now today, I'll tell you what we're going to do later. But for radical x is actually one of the shapes I'd like you to become familiar with. We're going to be graphing this more and more. Y equals radical x. It is not the same as y equals square root of x. Y equals radical x. Can anybody tell me what kind of x's we're allowed to use?
Positive.
Positives. What's the lowest you could go?
1.
Safely, 0. You can plug in a 0. Did we see that 0, 0 is the very first point you could possibly use? And then 1, 1, I'm just gonna try plugging in numbers. 1, Pete, take over. 1, what?
1, maybe radical 1?
Yeah, what is radical 1?
1.
1. Try 2, x equals 2.
Would that be radical 2?
Radical 2, and I'm not sure what that is, 1 point something. What's the first nice x after 1? For this?
Would that be
4.
4?
4, what?
4, 2?
4, 2, exactly. If you notice, you're making half of a parabola that's going sideways. Y equals radical x only has positive answers. So it only has the upper part. If it were plus minus, you would have the entire parabola. But for now, don't worry about it. So there's our graph. Somebody give me the inverse.
X equals the square root of y?
Yeah, x equals radical y. How do you graph it? A lot of people think that once they get this formula, they have to use this formula to graph it. We do not. What's the shortcut? Julie Lynn. How do you graph an inverse without even bothering with the formula? Let's just say you have this. How do you get an inverse again?
I don't remember. I have to
Okay.
check my notes.
Okay, go for it. To get any inverse, there's one key step.
Wait, where am I? You come back to me.
Okay, so an inverse, how do you get an inverse? Go.
Swap that with Y.
You swap the x and y. It's reflecting over the line y equals x, but put a big note in there, that's how you get an inverse. Swap x and y. Not only in the formula, you notice that's what we did? I replaced y with x and x with y.
Yeah.
You can do that with the individual points. This is 0, 0, 1, 1, 2, 4. So give me the inverse. What's the inverse of this?
0, 0.
Still 0, 0. And
1, 1.
1, 1, that's identical.
And then up to over 2.
Oh, I'm sorry, I wrote these backwards. This is 4, 2.
Wait, what?
The original was 4, 2, I wrote
Okay,
it
so
wrong.
up to,
Yeah, or, this is, yeah,
I'm sorry, over 2
over 2?
of 4.
Correct. And if you recognize, that's the right-hand side of a parabola that's going upward. You're done. Once you get the original graph, the inverse graph is not too bad. You just flip every single point you can find. That, by the way, would have worked on 1, 2, 3, and 4. If you have individual points, just trade the x's and y's, and you'll get the new one. Okay? That's number 12. And last but not least, number 15. Test each to see if your graph has symmetry in x-axis, y-axis, the line y equals x, and the origin. They did not test for y equals negative x, which is kind of annoying. But I can tell you it does or not. Number 15a, the only thing that has symmetry with is the origin. All the other ones are no. For B, it has symmetry in all of them. And for C, it has symmetry around the origin only. And it repeats. Yeah, so
It was 15A.
15A, the only symmetry is around the origin. All the other ones fail. Any others? Questions? Anybody want to see the ones in 15 work? Be okay on how to test for symmetry? Like, you gotta know the 5 different reflections. Actually do the substitution, like, negative x for x, or swap x and y, or whatever you do. Then simplify and see if the original formula matches the new formula. If they're identical, then you're looking at something that's symmetric. If it isn't, then it's not symmetric. Does that make sense? Questions? Now again, if you're not totally comfortable with being able to do that on the test, like now, I should be asking questions. You all sure? Okay. There's a difference between I'm quiet because I'm tired and I'm quiet because I've totally got this, thanks much. Take out your notes, please. I want to talk a bit about.
What was that? It was? Oh my gosh, how did it make that noise?
Hit-
Wow. Yeah, I saw it. It's like,
What is it going to be?
I couldn't even react. I was just like.
It's a mild terrorist attack, it's not more.
And we just thought like that thing.
We know how to get radicals out of it.
But the building.
All right.
Wow, I saw that in like my TV.
Oh, yeah. It's all on video.
Oh, that's right.
Great, when you go watch. They're gonna be like, that wasn't that loud. Or they're gonna be watching it, scared of them.
There are two different types of function I want to highlight today. Even functions, odd functions, and ones that are neither. What is an even function? By definition, and this is a pretty short definition, but it's, you have to kind of stare at it and translate it. Even function is this. If you try to plug in negative x, it'll give you the exact same answer as if you plugged in positive x. Odd function is this. If you try to plug in a negative input, you'll get a negative output. So if you change the input, you'll change the output. And then neither, you get something completely different. Take note, the test for whether it's even, odd, or neither, you have to plug in the opposite of the regular input. Instead of plugging in x, you plug in negative x and see what happens. That's the test for this. What does this mean? An even function, if you plug in a negative, it doesn't care. It stays positive. The metaphor I use is, you know somebody who's nice and even-tempered? You can plug negative inputs into them, psychologically speaking, and they'll still be nice and even-tempered. For example, pretend I'm even-tempered. I like to hope so.
You are.
Thank you. The first example that the first example I have is is he in? No. Was he wearing sunglasses?
He was playing super.
Okay, that was
I don't know why that was so funny.
whatever. Okay, for the people listening at home, there was this pretty it looks like Father Ron walked by, and he's dressed in dark usually, but I thought he was wearing sunglasses.
I don't know.
And-
They like Matrix symbols?
Yeah.
Yeah, they're like the dark, can't see your pupils, the
It was funny.
can't see eyeballs at all. Okay, anyway, moving
It
on.
really was.
Just so you know, the example of even. Assume for the sake of argument. Assume for the sake of argument that I mean even-tempered. I mean in the mathematical sense, which means, Mr. Conklin, somebody just gave you $50. Oh, that's nice. Mr. Conklin, somebody just slashed your tires. That's okay. In other words, positive input, positive output. Negative input, still positive output. Positive or negative inputs don't make any difference to me. I'm even-tempered. Does that make sense? For example, f of x equals x squared. Now, the way to test is to do a regular input and then the opposite input and see what happens. Like, let's f of 5. Go ahead and calculate that, somebody. Anybody. What would you get? 25. Does that make sense? What's f of negative 5? 25. Notice the two answers? Did they change? No. When I switched from positive to negative input, it made no difference. This is an even-tempered function, what we call an even function. Like that. Odd function, on the other hand, has a bit of a temper control problem. If you plug in a negative input, it goes all negative on you. For example, f of x equals x to the third power. Now let's try the two inputs and see what happens. Let's try 2 and negative 2, because they're nice and small. What's up of 2 in this case? If you cube it. 8. What's up of negative 2? Negative 8. You notice the answers? Did they change? Yeah, when you switch the input, it switched the output. That's an odd function. For example, let's pretend for the sake of argument that I have an odd temperament, which there's some argument for that. If I say, Mr. Conklin, somebody just gave me $50. That's good. Mr. Conklin, somebody just looked at you funny. Kill. So, in other words, if negative input comes in, negative output goes out for an odd function. Neither. This is where, if you try the positive and negative versions, actually one of the easiest ones I can think of is x squared plus x cubed. If you add them both together, you get some interesting results. Let's try f of 2 and f of negative 2. So what's up to 2? Put them in both slots though. So 2 squared is, 4 plus 8, so it's 12. Try the cube version. The negative version, I mean. What's this one going to be?
Negative 4. Sorry, I mean, that's gonna be 4.
Positive 4.
But it's
Plus.
gonna be negative 4.
Negative
8.
8.
Negative 4.
Yeah, so the answer is negative 4. So when you went from when you did the opposite of the input, did it do the same output? Like even? No. Did it do the opposite output, like odd? No, it just went psycho. Example. Mr. Conklin, somebody just gave you $50. Mr. Conklin, somebody just stole your battery. Do you ever wonder if a weasel spin on its nose for 24 miles per hour clockwise, would that affect the Earth's gravitational pull? What? Where did that come from? In other words, just totally random. It has nothing to do with the original one whatsoever. Okay, quick aside. I think I've said this before. One of my favorite comedians, his name is Stephen Wright, W-R-I-G-H-T. He is sometimes called Mr. Surreal. I have to do that. I have to take a mask off. So I'm going to step back. He comes up, he has this big, bushy, I mean, it's kind of gray now, but this big, bushy, black hair, kind of bald on top, like sticking out to here. And it would kind of, sort of, only like with receding hairline.
Ew.
And he's an interesting looking guy. And they'd say, oh, okay, ladies and gentlemen, please give a warm welcome to Stephen Wright. And people just go crazy because he's very popular. And he goes up to the microphone and thanks. And everybody busts out laughing. And then he just starts saying really random things like, I just got some spot remover. Now I can't find my dog. His dog is named Spot. Yeah. And then I just had a circular driveway installed in my house.
Oh, people are cheering?
Well, they laugh. It usually takes about 30 seconds for them to figure out, okay, oh, that's what he meant. So, yes, I just had a circular driveway installed in my house. And this is almost exactly what he sounds like. No, I can't get out. So, I live in an apartment, I have a dog, and there's not much room, so I decided to give him some exercise, so I walked him on the ledge. Somebody sort of random stuff. So like an hour of this. It'd take a little while. But did you ever see the old maps where that, like, the paper maps where they'd have like A, B, C, D, E, F, G across the top, and then 1, 2, 3, 4, 5, 6, 7 down there? So you could find like, you know, Ada, Michigan is like at C4 or something like that. And then down at the bottom, it's like scale, like 1 inch equals 100 miles. Recently acquired the largest scale map of the United States. Scale is 1 mile equals 1 mile. When people ask me where I live, I say E4. No, it's not, all right, that's a random, but, I also acquired the world's largest collection of seashells. I store them on all the beaches in the world. Maybe you've seen them.
Is this all of his county?
Yeah, it gets pretty much like, just, I just installed a second motor in my car. Now it goes 260 miles an hour. I started taking harmonica lessons, but the only way I know how to play the harmonica is to rev my car up to 130 miles an hour and hold it out the window. Then I drove in my new car. The harmonica sounds amazing. Anyway, look him up on Steve. There are a couple of his skits that are a little off color, but you can fast forward those. They're totally, if you're into that sort of thing, they're hilarious. If you're not, you can spend 45 minutes going, what? Seriously? Okay. Anyway, the reason I read, wow, that was a long tangent with not much relevance. That's kind of like, this is like the Stephen Wright function. If you put something normal in, you get something completely random out. So, there you go. Now, what does this have to do with math? Glad you asked. The two problems I had you skip, problems 31 and 33. 31, it said classify as even, odd, or neither. The way you test is you put in a positive number, pick an number you want, and then plug in the negative version of that number. I'm going to attach that. The 31 and 33, they're actually going to be pretty fast. 31 and 33 together are probably going to take you about 2 minutes. So I'm going to attach that to homework 4D, which is relatively short too. It has more happening inside. But 31 and 33, for example, look at number 31A. They have f of x equals x squared. You can guess what that is. Even, odd, or neither? We already did it, so. Oh, sorry, page 137. F of x equals, I actually did 2 of them for you. What do you think? Yeah, number 31A. It's even. Yeah, that was actually the example I used for an even function. How do you test it? Pick any number you want, plug it in, and then plug in the opposite of that number and see what happens. I would recommend you not plug in 0. Because when you try and plug in -0, you won't get much of a difference. Wow, everything's even. No, you're plugging in 0. So plug in something other than gentlemen. Not done. So number 31, you should be set to go on 31A through F. 33. What kind of symmetry does an even function have? Question. Looky here. Can anybody tell me what reflection that is? It's called opposite x. It's over the y-axis. They're claiming that doing the opposite x is the same as doing the regular x. So what symmetry does that thing have? Yeah.
Symmetry over the y-axis.
Y-axis symmetry, correct. Symmetry over the y-axis. In other words, if you do the y-axis flip and it says it's the exact same graph, you've got symmetry there. How about odd? Are there any symmetries that show up here? Let me give you the graph of an odd function. This is actually one of the easiest of the odd functions. This is an odd function. How do I know? If I change opposite x, it turns to opposite y. Let me look up here. Does this thing have symmetry anywhere? Does it have symmetry over the x-axis? Like this is over 1 up 2. Like if you flip it over the x-axis, would it be identical? No, it would be going downhill at -2. What if you flip it over the y-axis? Is it identical? No, it's going downhill as well. Is there any symmetry that would work? How about x equals y? Y equals x. If you bounce it over that, would it be identical? No. Think of it as you folding this and seeing where the ink smear is. That would be like down here. Is there any symmetry at all?
What do you mean identical?
Oh, identical means that if you fold it and you unfold it, you couldn't tell the difference. Like for example, if you have a circle,
Yeah.
the smear would be the exact same place.
Yeah.
So you couldn't tell, yeah.
The origin.
The origin. This has symmetry over the origin. Prove it. How do you reflect over the origin? Start from yesterday. Look in your notes.
X and negative y.
Opposite x, opposite y. So negative y equals 2 times negative x. Simplify. So negative y equals,
Negative 2x.
solve for y.
Divided by negative 1 both sides.
Okay?
And then y equals 2x.
How does that compare to your original?
It's identical.
It's identical. This has origin symmetry. By the way, what they were probably expecting you to do on 33A and 33B, test the 5 different types of reflection and see if any of them work. I'll tell you right now, only one of them is expected to work for each. And you should have the answers to those now. So actually the 31 and 33 are nailed down. You just need to copy them. For D, just so you know, there's not a lot to do. We already covered moves, resizes, and flips. And then the homework you did was nothing but flips. Now they're doing moves and resizes. So if they wanted to move something 3 spaces to the right, 4 spaces to the left, etc. There's just one term well, 2 terms I'd like you to do as closing notes for today. Periodic function. Periodic function is a function that repeats. So one repeat cycle, whoops, I can spell, is called a period. So if you have a periodic graph, like something that periodically happens, like the yearly cycle, we get, like the time of day that the sun sets, it gets later and later and later, then it gets earlier, and it keeps cycling back and forth. You can predict with mathematical almost certainty when the sun is going to set next year, September 30th. You can just look it up on a chart, aha. And the reason they can do that is because it's predictable. It goes over and over and over and over. Okay. And we're actually going to study the graphs that do that in the 4th quarter. For now, one cycle is called a period. You might have to say how long is a period. Look please on page 142. I'm going to do, you see those class exercises which are not part of the homework? I'm just using this as an example. Question, is that function periodic, in your opinion? We're on page 142, just the sample. Is that periodic? How do you tell if it's periodic or not?
Sorry, 142.
Problem number 1 in the class exercises. So not any homework problems, just for trial. It does repeat, yes. how long is the period? Look carefully. A lot of people get this wrong. One complete cycle would be one period. What is it?
4.
It's 4. A lot of people say 3, because they just see the up, across, down. They forget to do that little valley thing from 3 to 4. So we see that? So the period is 4 units long. Now look at number 1 in the written exercises. Is that periodic? Yes, it is. Can anybody tell me the length of the period?
4.
The length, well,
Oh, 3?
and one complete cycle before it starts over again. You might have to go back a few steps to see the start. I give you a hint. Look for the minimum. Look for the minimum height. That's usually the good place to start. Do you see how it goes like a capital letter M? So up, down, that's the cycle. How long is that? Okay. Number 1. Everybody on the same page? Page 143? Okay. Start at, there's a minimum at x equals -2. -2 comma -1. Follow the graph up, then down a little, then up, then all the way down. Do you notice that if you go up and then down a little, it's not done? A cycle keeps going. How long is the whole cycle? Oh, like how far over do you go before it starts repeating? What's the length of the period?
4?
We start at -2. And then by the time you get back down to that height, it's over at 4. Close. If there's 2 spaces on the left-hand side and 4 spaces on the right-hand side, 6. The period is 6.
So it's by spaces, not by move?
Correct. We're not moving. We're just counting how long it would take before it repeats again. So if let me read this.
Oh, well, it's not like each increment, it's like 1, 2, 3, 4, that's each period. So it's not like it goes up and down, up and down. You don't count ups and downs, you count how far.
Right. This would be 1 period. Like how long is that? Do you see why if I only went to here, it wouldn't be done? You can start anywhere you want, just make sure you've gone through 1 complete cycle, no more, no less. Usually if you start at the max or the min, it's easier to count. If you start in the middle of, okay, if you start in the middle of nowhere, it's really hard to see. Okay. Number 2, does that look like it's periodic? Yeah, it does. It looks like it's repeating. Somebody tell me how big the period is. How long does it take to repeat? This one you can probably start counting from 0. Because there's a cycle that starts at 0. It's kind of like an EKG. So it has 2 little mountains and then a spike. And then 2 little mountains and a spike. What's that?
I gotta go.
Oh, sure, go for it. Go for it. 0.8. That's the period. Does that make sense? Okay. Last word. Amplitude. You need to check the video later for this stuff if you need to. Amplitude, last thing I want you to write in your notes. Amplitude is what we call vertical radius. So if I have a graph that's going like this, and that's a sloppy graph, this is the amplitude. This is also the amplitude. In other words, how big is this radius from the center height?
Thank you, Mr. Cobb.
No problem, thank you. Everybody good with that? And we are just about out of time. towards D as in Douglas. And the last two problems of 4C. So numbers 4C, 31 and 33, and 4D in its entirety. I would like that for tomorrow, which is Tuesday. Okay? That should do it, and we are out of time. So please stand. Let us pray. Right. Let us pray. In the name of the Father, the Son, and of the Holy Spirit. Amen. Glory be to the Father, to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. In the name of the Father, the Son, and of the Holy Spirit. Alrighty. People at home, see you later. Everybody here.